Today we're going to talk about solving radical equations. And if we solve radical equations, it also means we could solve exponential equations. First, we're going to talk about solving radical. If you're going to solve a radical, you must get the radical expression alone. To do this, you apply the inverse to both sides of the equation. For example, if my problem reads the cube root of x, to undo that, I would have to raise it to the third power. Likewise, if my equation is written in exponential form, I want to get the exponential expression alone. And then raise that variable to the reciprocal power, so it will have a power of 1, and then it will read x equals. And what I do to one side of the equation, I must always remember to do to the other side to keep equality. If you take your handout, you should have these problems on there, and we're going to work one of them out, each one of them out, one at a time. So 5 minus the fourth root of x equals 0. The radical expression is the fourth root of x. So I want to get rid of everything else first. So I would have to subtract 5 from both sides. And I get a negative fourth root of x equals negative 5. Divide by a negative 1 because I want that fourth root alone. I don't want anything else with this. So I get the fourth root of x equals 5. How do you undo a fourth root? We would raise it to the fourth power. So x would equal 5 to the fourth. 5 times 5 is 25. 25 times 25 is 625. We can always check if our answer is right or extraneous by substituting it back in. So 5 minus the fourth root of 625 equals 0. 5 minus 5 equals 0. 0 equals 0, so it checks out. So 625 is my solution. In this next one, the square root of 2x plus 8 minus 4 equals 6. The square root of 2x plus 8 is my radical. So I want to remove everything else over to the other side. So the opposite of subtracting 4 is to add 4. So the square root of 2x plus 8 equals 10. How do you undo a square root? We would square both sides. So I get 2x plus 8 equals 100. Now it's a simple equation to solve. Subtract 8. 2x equals 92. Divide by 2. X equals 46. We can double check. 2 times 46 is 92, plus 8 is 100. Square root of 100 minus 4 equals 6. 10 minus 4 equals 6. 6 equals 6. Checks out. So I know 46 is the correct answer. Okay. The next problem we have should be 3 times x to the 4 thirds equals 243. This time it's not radical, but exponential. And my exponential part is 3x to the 4 thirds. So I want to divide both sides by the 3, so I get just the x alone. And I have x to the 4 thirds equals 81. How do you undo raising something to the 4 thirds power? Remember, I want this to be x to the 1. So I would have to raise this to the reciprocal of 4 thirds, which is 3/4. Because power to power, when I multiply, I get a 1. So what I do to one side of the equal sign, I must do to the other. So this gives me x. And can you evaluate 81 to the 3/4 like that? No, we would have to rewrite it in radical form. So it is the fourth root of 81 cubed. And remember, in radical form, you always do the radical first. So we get x equals 3 cubed, which is 27. And if we put 27 back in here, we would have 3 times the cube root of 27 to the 4th. Does it equal 243? 3 times cube root of 27 is 3 to the 4th. It's 243. That's 3 times 81, and that is 243. So it does check out. Okay. This time, we have 2 radical expressions on the same side of the equal. Now, just to square both those would mean we're going to have a radical still in the middle. So the best thing would be to add this part, 3 square root of 2x, to both sides of the equal. And you have the square root of 4x plus 28 equals 3 square roots of 2x. Now we can square both sides. This squared just gives me what's under the radical, 4x plus 28. 3 squared is 9. Square root of 2x squared is 2x. So I have 4x plus 28 equals 18x. Subtract 4x. 28 equals 14x. Divide by 14. X equals 2. If we double check that, 4 times 2 is 8, plus 28 is 36. 2 times 2 is 4, square rooted is 2, times 3 is 6. 36 minus 6. Square root of 36 minus 6, 0. Yes, 6. Oops, 6 minus 6 is 0. Oh, stop moving. So it does check out. Okay. Your next one, x minus 4 equals a negative 6. This is my radical, square root of x minus 4. So I have nothing else to remove, so I would square both sides. So that is x minus 4 equals a negative squared is a positive, and 6 squared is 36. Add 4, x equals 40. If I check that, 40 minus 4 is square root of 36 equals a negative 6. 6 equals negative 6. No, it does not. It does not check out. So this is extraneous. It's a root that does not make sense, an extra root. So since that was our only choice, it means there is no solution to this one. This time, 2x plus 28 is my radical. So I must square both sides. So I have to square the entire quantity of x plus 2 as well as the square root of 2x plus 28. So this, some of you may have to FOIL. X squared, 2x and 2x is 4x. 2 times 2 is 4 equals 2x plus 28. And when you have a square, you want to put everything on one side of the equal and see if you can factor it. So I need to subtract the 2x. X squared plus 2x plus 4 would equal 28. I need to subtract the 28. X squared plus 2x minus 24 equals 0. And this is where I factor. X squared, I'll factor into x and x. And then you want to say the factors of 24 that differ by 2 would be 4 and 6. positive, negative, because inside here I have positive 4x, outside here I have negative 6x. Negative 6 and positive 4 make negative 2. I need positive 2, so this has to be the plus, and this has to be the minus. Negative 4, positive 6, yes, that does make positive 2. So x equals 4 or x equals negative 6. And we should check. 4 plus 2 is 6 equals 8 plus 28 is 36, square rooted is 6. So that one checks out. And I put negative 6. Negative 6 plus 2 is negative 4. Put negative 6 in there. Negative 12 plus 28 is 16. Square rooted is positive 4. So that one does not check out. So this time my only solution would be 4. So you're always going to have to make sure you double check for extraneous roots. And if you notice, all our square roots can cause extraneous. All our even roots. Let's see if that works with cube roots. My radical is cube root x. So I want to get rid of everything else. So first I would subtract 6. And I have negative 2 cube root x equals 6. Divide by the negative 2. Cube root x equals negative 3. To undo a cube, I must raise it to the third power. So I get x, a negative to the third power, negative 1, negative 1, negative 1 is a negative. 3 to the third is 27. So if we double check this, negative 2 times the cube root of a negative 27 plus 6 equals 12. A negative 2 times cube root of a negative 27, negative 3 plus 6 equals 12. 6 plus 6 equals 12. Yes, it does. 12 equals 12. So it checks out. So the cube root does not matter. So give these a try, and we'll go through them tomorrow.